My name is Kannan. I have completed MSc Operations Research in NIT Trichy. I have 33 years of experience of teaching engineering mathematics, 11th, 12th, state and cbse maths. Now I will take the chapter on differential calculus. Differential calculus. First of all, we see meaning of differentiations. Meaning of differentiations. The actually differentiation means rate of change of functions with respect to variable. Example of differentiation is rate of change of populations with respect to year. Okay, when year changes, population also changes. That is an example for differentiations or derivatives. There are two meaning of differentiations. Actually, three meaning. First one is geometrical meaning. Second one is mathematical meaning. Third one is physical meaning. Okay. First of all, we see geometric meaning. Geometrical meaning. Now consider the functions. Y equal to f of x. Okay. We draw a curve for the functions y equal to f of x. This is x-axis and y-axis. And I draw a curve like this. Now this point is taken as A, this point is taken as B, length of OA is x, okay, therefore this point is x here, and AB, length of AB is delta x. Delta x is the increment of x value. The position of B is now x plus delta x after increase of delta x from x value. Now we have to plot these points on the curve. Now at the point x, the coordinate is x comma f of x. At x, the function value is f of x. Okay. Similarly, I am take the point as d. This coordinate is okay. X plus delta x and f of x plus delta x. Okay, join these 2 points. Okay, and now this line is called a chord. What is chord? Chord means line joining the 2 points on the curve is called chord. Okay. But chord is nothing but straight line. The special name is line joining the 2 points on the curve is called chord. Okay, now you have to find the slope of the chord. We know about slope. A ratio between difference of y value and the difference of x value. That is rise by run. That is called slope. Okay. That is y2 minus y1 by x2 minus x1. That is, here x1 even is x comma f of x, and x2 y2 is x plus delta x and f of x plus delta x. Okay, we substitute. So f of x plus delta x minus f of x divided by x plus delta x minus x. This is called slope of chord. Okay, so we get x cancel the denominator, so it became delta x. This is called slope of chord. Next, I decrease the length of delta x. Okay, the new position is this point. Okay, I am taking this as b dash. So now the chord is like this. Okay, again I decrease the value of delta x. The new position of the chord is like this. Okay, so every time I am decreasing the value of delta x, that means the point B approach to the point A when delta x decreases. Okay, when delta x decreases its value, the point B comes to very closer to A. Okay, that means delta x approaches 0. When the point B approach to the point A, it means delta x approach to 0. Okay, so when delta x approach to 0, the chord become like this. Okay, the chord become like this straight line. This line is called tangent. Tangent means the line passes through only one point on the curve is called tangent. Okay, now the chord become tangent. Okay, when will the chord become tangent? When will the chord become tangent? If delta x approaches 0. Okay, when delta x approaches 0, the slope of chord become slope of tangent. Okay, now I am writing slope of tangent. So now the slope of tangent is limit delta x tends to 0, f of x plus delta x minus f of x by delta x. Okay, that is, we derive the slope of the chord. We derive the slope of tangent from the chord. Okay, so this is called as derivatives. This is called as derivatives. Okay, so the notation of the derivative is d. D means derivatives or the functions with respect to x. A limit delta x. This is the mathematical meaning of derivatives. Okay, this is the mathematical meaning of derivatives. This is the mathematical meaning of derivatives. Okay, so what is the geometrical meaning? What is the geometrical meaning? Geometrical meaning of derivative is slope of tangent at a point. Okay, geometrical meaning of a derivative is slope of tangent slope of tangent at a point, at a given point. Okay, that is a geometrical meaning. Okay, mathematical meaning of derivative is limit delta x tends to 0, f of x plus delta x minus f of x by delta x. So you see, this is the formula to find derivative of any functions with respect to x if derivative exists. Okay, if derivative exists, if the derivative exists, we can find the derivative of the functions with respect to x. Okay, now we have to find derivative of the function f of x equal to x square. To find the derivative of f of x square. Okay, this is actually fundamental formula or first principle. Okay, to find the derivative of x square. Now the function is x square and f of x plus delta x. Substitute x is equal to x plus delta x, so we get x plus delta x the whole square. Now write dy by dx or df of x by dx y or f of x, both are same. Limit delta x tends to 0, f of x plus delta x minus f of x by delta x. Now we substitute the values. Limit delta x tends to 0, f of x plus delta x plus delta x, the whole square minus f of x is x square divided by delta x. Now I expand by a plus b whole square formula. So limit delta x tends to 0, x square plus 2x delta x whole square minus x square by delta x. This x square get cancelled. Take out delta x. Take out delta x. So 2x plus delta x by delta x. Okay, delta x get cancelled. Now apply limit. We put delta x 0 here, 2x. Okay, so d by dx of x square is what? 2x. Okay, differentiation of x square is 2x. What is the geometrical meaning of 2x? 2x is the slope of tangent to the curve x square at a point x. That is the meaning. Okay, so every derivative is the slope of the tangent of the given functions. Okay, next to find derivative of function f of x equals sin x. To find the derivative of f of x equals sin x. Okay, sin x is one of the trigonometrical functions. Now take f of x equal to sin x. F of x plus delta x equals sin of x plus delta x. Now write dy by dx. Limit delta x tends to 0, f of x plus delta x minus f of x divided by delta x. Now we substitute the values. Sin of x plus delta x minus sin x divided by delta x. Now simplify the numerator by using the sin c minus sin t formula. That is 2 cos of c plus d by 2 sine of c minus d by 2. Okay, what is c here? C is x plus delta x, d is x. Okay, simplify, then apply limit. So limit delta x tends to 0, 2 cos of c plus d by 2, that is x plus delta x plus x divided by 2 sine of c minus d by 2, x plus delta x minus x divided by 2 here, divided by delta x in the bottom. So limit delta x tends to 0. And now write 2 cos x plus x is 2x plus delta x by 2, x cancel. So this x cancel. So delta x by 2 divided by delta x. In the next step, I bring these two to in the bottom. Okay. So limit delta x tends to 0. First write cos 2x plus delta x by 2 and sine of delta x by 2 divided by delta x by 2. Okay. Now apply limit now. Before applying the limit, I tell one result on limit x tends to 0, sin x by x is 1. Okay. Similarly, limit x tends to 0, tan x by x is 1. Okay. This is the result in limit function, limit of the functions. Okay. So limit delta x tends to 0. Here, instead of we write in the formula, we write sin x by x, but in this problem, instead of x, we get delta x by 2. Okay. So we apply limit, it become 1. This become 1 after applying the limit. Okay. Now apply the limit separately for cos and sine. Sin delta x by 2 by delta x by 2. So in the cos function, we apply limit here. Cos of 2x plus 0, delta x is 0 by 2. This become 1. Okay, 2 to cancel, we get cos x. So what is the derivative of sin x? That is cos x. That means cos x is the slope of tangent to the curve function sin x at a point x. Okay, that is the geometrical meaning of derivative of sin x. Similarly, I am giving all the results for a derivative of the functions. Okay, first result is y equal constant, dy by dx equal to 0. Okay, because constant is always constant. Constant is always constant. It never changes. Okay, 2 is always 2 at any time. That means no rate of change of any constant. We can't change the constant value. Okay, so dy by dx is 0. We can't do anything with the constant. Constant is always constant. It never changes. So never means 0. Okay, I am writing 0. Okay. Next one is, so y is equal to x power n. Dy by dx is n into x power n minus 1. Okay. D means derivative of functions with respect to x. Third, y is equal to, I am taking exponential functions, a power x. Dy by dx is a power x log a. Okay. log a must be greater than 0. Okay. Fourth one is e power x. Dy by dx is again e power x. We get log e base e. Log e base e is 1. So we write the same e power x. Okay. One is y is equal to log x. Dy by dx is 1 by x. Okay. X is always greater than 0. X is always greater than 0, not equal to 0. Okay. And also positive. Never negative. Okay. Sin x. Dy by dx is cos x. Differentiation of sin x is cos x. Okay. Y equal to cos x. Dy by dx equal to minus sin x. Eighth one is tan x. Differentiation of tan x is secant square x. Sec cot x. So y equal to secant x. Secant x tan x. Okay. Y equal to cosine x. Dy by dx is minus cosine x cot x. Okay. So these are all different formula to find derivatives. 12th one is product rule. So y equal to here two functions are in product. Y equal to uv. U is the first function and v is the second functions. Then dy by dx is first write u, differentiate v, plus write v, differentiate u, that is dy by dx. Next one is quotient rule. So y equal to u by v. So dy by dx is, all the results are derived from fundamental formula. Okay. V square, write v here, differentiate u d by dx minus u, differentiate dv by dx. This is a quotient rule. Thank you. We will see more in next video.